This PowerPoint video is going to go through all the measurements needed to complete the lab and also discuss some of the calculations. So let's start with Station 1. So for Station 1, you need to calculate the density of a cube. In order to do that, you're going to need to measure the length, width, and height of the cube using the following pictures. Note that all measurements taken, not just in Station 1, but the other stations as well, will be with the centimeter side of the ruler. When you're taking the measurements, or recording the measurements, I should say, you're going to make sure to take significant figures into account. So what that means is if you're using a ruler and it has 0.1 increments, your measurement should go out one further than that. So let's start by looking at the length of a cube. So for Station 1, you need to measure length, width, and height. Notice I only have one measurement on here. So in the first picture to the left, I'm showing the cube being measured with calipers. So calipers is just a more accurate ruler that's going to help us measure smaller things. In the picture to the right, that's just a close-up of that same measurement. So why am I only showing one measurement? Well, because with a cube, the length, width, and height are all going to be the same. So I only needed to measure one dimension. When you're using the caliper and trying to figure out what the measurement is, you're not going to be measuring from the edge of this ruler. Okay, that's going to be incorrect. So this cube, the first measurement here, is not 2.4 because we don't want to measure from that edge. Where we want to measure from is where this 0 is. So that 0 dash is where we want to measure from. So looking at where that dash is, you figure out what the measurement is. So you're going to record the measurement yourself. Make sure when you're recording that you're going out 2 decimal places. So you will write that measurement for both the length, the width, and the height. So make sure you're writing it for all 3. We are measuring again in centimeters. So with the measurement done, let's look at the mass. So the mass of the cube, I went and took the cube and put it on one of the scales in lab, and you can see the mass down below the pictures, 128.66 grams. So you can include that in your data sheet as well. Next, you'll see it asks you to calculate the volume of the cube. It gives you an equation where you are taking the length times the width times the height. So whatever you got for the measurement here, you're going to multiply that 3 times, or cube it, essentially. Whatever you get for your answer, make sure to use the units of centimeters cubed, since we took centimeters times centimeters times centimeters, and take into account your significant figures. The last calculation you need to do is density. So density is mass divided by volume. So the mass is given to you at the bottom of the slide, 128.66 grams. The volume you will calculate using the measurement on this slide. So you will take those 2 values, divide them to get your density. The units on density are going to be grams per centimeter cubed. So the reason we're trying to calculate the density of this cube is because we're trying to figure out what material the cube is made out of. So for the last question, it asks you to identify the material and calculate the percent error. So how do you know what material the cube is made out of? Well, you take the density that you calculated on the previous slide, and you're going to compare it to the densities in this table. So you can notice a list of densities on the right-hand side, and the material corresponding to those densities on the left-hand side. All densities are measured in grams per centimeter cubed, just like you measured it in on the previous slide. So you're going to pick what the cube is made out of based off of what density matches most closely with yours. They're not going to be exact, but they will be close if you did the measurement on that ruler correctly. Once you know what the material is, you're going to identify the material, so write it down. For instance, if you calculated a density that was close to the density of iron, you would then write the material is iron. At that point, you can calculate your percent error. So let's look how we're going to calculate that percent error. So the equation for percent error is measured minus true divided by true multiplied by 100 to get it in a percent. So notice around the subtraction portion of that equation there are bars. Those are called absolute value bars. And what those mean is that if you happen to do the subtraction and get a negative number, you need to change that to a positive. That's all it means. You're not going to change the actual number itself. You're just going to change the negative to a positive. So how do you know what is the measured and what is the true? Well, your measured is going to be the density that you calculated using the measurements given. The true is going to be the density that you located from the table on the previous slide. So once you identified what your material was, you saw a corresponding density to what the actual density should be. So let's look at an example. Say you calculated your density using your measurements to be 7.3 grams per mil. Looking at the table, the closest material that had that density was zinc. Now, its density wasn't 7.3, but it's close. It's 7.13. So when you're using these values to calculate percent error, you're going to take the 7.3, the density you calculated, and put it in the measured spot. You'll take the density you got from the table, corresponding to the material that you identified the cube as, and put it in the true spots. So it'll go in two different places. Subtract the top, divide by what's on the bottom. Don't forget to multiply by 100 to get a percent. And in this case, I got 2.4%. Now, your material might not be zinc. When you do the calculation, it could be aluminum or iron. So you're going to use your density values and the density value from the table that you identify to do your calculation. Let's move on to station 2. So station 2, we're going to be doing the same steps, except for this time we're going to be calculating the density of a cylinder. So instead of a cube, we're doing a cylinder. Since it's a different shape, it's going to have a different equation for calculating the volume. So to calculate the volume of a cylinder, we're going to be taking the equation pi r squared times L. When we take our measurements, we're not actually going to take the measurement of the radius, so we're going to have to calculate that as well, which is why I have a second equation here, where it says r is equal to 1/2 d. The mass of the cylinder is given to you, 28.98 grams. So that will go in your first empty slot for mass. You're going to calculate the volume using the photos that are coming up next, so that you can then plug those numbers in to calculate for the density. So let's look at the measurements of the cylinder so that we can go ahead and calculate that volume. First measurement we're going to take is the length of the cylinder. So L is equal to, remember, we're using centimeters. So to figure this out, you can see this cylinder shape with the calipers, and the next picture is just a close-up of that. So make sure you're taking the measurement from where this 0 dash is. Next, we're going to calculate or measure the diameter of the cylinder. So diameter is the widest part of the circle. So you'll notice in the picture I'm measuring the widest part of the circle between the calipers. The next picture is a close-up where you're going to want to take the measurement from where the 0 dash is. Remember, each dash is worth 0.1. So we have 1.1, 1.2, 1.3, 1.4, 1.5, and so on and so forth. Once you get that diameter measurement, it then asks you to calculate the radius of a cylinder. So to do that, you're just going to take the diameter and divide it by 2, because the radius is equal to half the diameter. So whatever you get for this measurement, divide it by 2 to get the radius. Don't forget your units. Now we have the length measured. The radius is calculated based off of what we measured for the diameter using this equation. And then pi is 3.14. And you have that function on your calculator. So now you have all you need to calculate the volume. Then take this volume and plug it in to the density equation. In the denominator, you will take the mass given to you in grams and plug that in to the numerator. This will give you your density in grams per centimeter cubed. You will then use that density and compare it to the densities on this table so that you can identify the material that that cylinder is made out of. You will then calculate percent error, just like you did for the cube. Next, station 3, we're going to calculate and identify the material that the sphere is made out of. So with the sphere, first, the mass of the sphere, 67.16 grams. Next, you need to measure the diameter. And I have that measured in the photo off to the right. So you will use that picture to determine the diameter of the sphere. Once again, remembering to take the measurement from this 0 dash mark. Once you have your diameter, you then divide your diameter by 2 to get your radius. So the radius is a calculation based off your diameter measurement. So the reason we need the radius is because you'll see the equation to solve for volume of a sphere is 4/3 pi r cubed. So you're going to take whatever you calculated for the radius, cube that value, multiply that value by pi, and then multiply it by 4/3. This will then give you the volume in centimeters cubed. You can use that calculated volume in the denominator portion of the density equation. We'll also take the mass and plug that in to the numerator to calculate for density in grams per centimeter cubed. Then go back to the table again and identify the material that the sphere is now made of based off of the density you calculated. Don't forget to calculate the percent error as well. See how close you are to the original value. Next is station 4. So for station 4, we're going to calculate the density of an irregularly shaped object. You can see the object pictured on the left. So due to the shape of that object, we're not able to measure it with a ruler and do volume calculations to figure out what the volume should be. So instead, what we're going to do is we're going to measure the volume of that object using a water displacement method. So what we have is an overflow spout. So that's what that metal can is called. It's called an overflow can. So to figure out the density of that irregularly shaped object, what we do is we fill up the can to the top with water, right below the spout. Then we place the irregular object into the water. Since that object is more dense than water, it's actually going to sink to the bottom of the can. When it does that, it's going to make the water level rise, displacing the water. When that water level rises, water is going to come out of this spout, out of the overflow can. So you'll notice there's a graduated cylinder underneath to catch that water. We catch the water coming out of the can and measure it with the graduated cylinder. Whatever level of water it rises to, that's equal to the volume of that irregular shape. Now let's look at the data collected. So the mass of that irregularly shaped object when put on the scale was 61.76 grams. Now to figure out the volume, so you'll notice in your lab manual it says volume of water displaced, and then it has a V is equal to. So what's going to go there is the volume that you're reading from this graduated cylinder here. This is the water that was collected from the spout when the irregularly shaped object was placed in the overflow can. So you can see the water level right here. So you want to use the graduated cylinder, and notice it's going by ones. So we have 10 down here, the next dash is 11, then 12, 13, all the way up to 20. So you can use this line here to figure out how many milliliters of water are in that graduated cylinder and record it in the appropriate place. So the reason why there are two volumes, it says volume of water displaced, that's going to be the volume you're reading right now in milliliters. When it asks then for volume of the object, that's actually the same number. It's the units that are going to be different. You're going to change it to centimeters cubed. So the reason the values or the numbers for those two empty spaces are the same is because 1 milliliter is actually equal to 1 centimeter cubed. They're interchangeable, so the same units can be used without changing the number value itself. Next, you can calculate the density of that object using your mass and volume. Again, it doesn't matter which volume you use because the numbers should be the same. It's only the units that are differing. Once you calculate the density, once again, compare to the table, identify the material, and calculate the percent error. So now let's look at Station 7. You're noticing I skipped Station 5 and Station 6. You can cross those out. We will not be completing those this semester in lab. We are skipping to Station 7, so do not do Station 5 or Station 6. Station 7 is determining the average density of a marble. So here we have a similar situation as with the irregular object. We're trying to measure several marbles, so instead of measuring each marble individually and calculating their volume, since they're spheres using the equation we used before, we're just going to do the water displacement method. Since the marbles are more dense than water, this method works. So if the marbles were less dense than water, they would just float along the top of that overflow can. They wouldn't sink. And if they were just floating on the top of the overflow can, on top of the water, and not sinking, they wouldn't displace any water, and no water would come out of that spout on the overflow can. But since they are more dense, we can use this method. So I took 10 marbles, took the mass of them, placed them in the overflow can, and what came out was the amount of water shown in the picture to the right. So once again, you're going to use this picture to figure out the volume. First, let's start by looking at how many marbles were used. You can count in the picture, but I also give it to you off to the right. There are 10 marbles. I also took the mass of those marbles. They were 54.90 grams. To figure out the volume, you're going to use the picture looking at the water level line and reading the graduated cylinder. You record that in milliliters because you're measuring water and liquids are recorded in milliliters. You then can convert that to centimeters cubed simply by changing the units, since 1 milliliter is equal to 1 centimeter cubed. You'll then notice that this one is a little bit different because it then asks you to calculate the average mass of a marble. So it wants to know what's the mass of just one marble. So to figure that out, you're going to take the mass of marbles that was given to you, and you are going to divide it by the number of marbles that we massed. To figure out the next one, the average volume, you're going to take the volume of the marbles, which is just the volume that you're measuring of that displaced water, and divide it by the number of marbles. Total of 10 in this case. You'll notice that it asks to calculate the average density of one marble. So we're not calculating the density of all 10, we're just going to calculate the density of one. And actually the calculation's the same, but to be safe, we'll just all calculate it the same way. So to figure out the average density of a marble, just one marble, you'll take whatever you got for the average mass and divide it by the average volume. Make sure you're doing those calculations correctly so you don't get that incorrect. So we want to know the density of the marble so that we can go and identify the material that those marbles are made out of. Once you find the material, calculate the percent error using the true value from the table and your calculated density value. Station 8 is calculating the number of pennies in an envelope. So to do that, see in the picture I have an empty envelope, an envelope with pennies in it. You can't see there's pennies in it, but trust me there is, and also a penny itself. So I massed the pennies in the envelope and got 64.93 grams. I also massed the penny all by itself. That penny was 2.49 grams. The empty envelope came out to be 6.77 grams. So you're going to use these values to figure out how many pennies you think are in the envelope. So how do you do that? Well, notice you have the mass of pennies with an envelope and the mass of just the envelope. So if you could subtract these two numbers, that would equal the mass of the pennies. This is more than one penny, it's all the pennies in that envelope. Once you have the mass of all the pennies in the envelope, you can figure out how many pennies by dividing that mass by the mass of just one penny. Make sure that you are rounding up. What I mean by that, sorry, this is horrible writing. Mass of one penny, okay. What I mean by that is once you get an answer for this, so once you take the mass of the pennies and divide it by the mass of just one penny, you're probably not going to get a whole number, but you need to round it to a whole number because I didn't take any of those pennies that are in that envelope and chop them in halves or thirds or quarters. Okay, they're all whole pennies. So round accordingly. Last station, station 9, determine the mass of copper and zinc in a brass cylinder. So I took the mass of a cylinder, I don't have it pictured here. It is 207.9 grams. So you're going to use that cylinder, which is made of brass. Now, with brass, that's an alloy. So what an alloy means is it's made up of two different metals combined. And the metals that it's made up of is copper and zinc. We know that 67% of that cylinder is made up of copper, and 33% of that cylinder is made up of zinc. So knowing those values, you need to calculate the grams, so how many grams of that is just copper, and how many grams of it is just zinc. You can do that by changing the percent into a decimal point and multiplying that by the mass of the cylinder. When you do calculate the mass that is just copper and the amount that is just zinc, keep in mind that the masses added together should equal 207.9 grams. If they do not, something went wrong. That is it for the lab, so let me know if you have any questions.